Welcome everyone to The Foundry by Forge College. I am absolutely thrilled you're tuning in today because we've got a genuinely fascinating explainer on the foundations of integrated deployment frameworks. Think of this as the exact moment we stop just, watching our systems and start actually controlling them. We're going to completely transform your passive metrics into an active, automated deployment factory. Let's get right into it.
So let's set the stage a bit. In our previous lesson, Automating Monitoring for Performance Optimization, you did some fantastic work. You instrumented your runtime metrics, you wired up real-time alerts to your observability stack, and you created a vital feedback channel. But I have to ask you a rather crucial question. What good is a state-of-the-art fire alarm if the doors don't automatically unlock when it goes off, right? You have the sensors, you have the alarms, but who, or more accurately, what, is actually listening to them during a live release?
Here is our blueprint for today's explainer. First, we'll unpack strategies versus frameworks. Second, we'll walk through the 5 integration steps. Third, we'll get our hands dirty coding a gate check. And fourth, we'll wrap up with the feedback loop.
All right, let's dive into Section 1, Strategies versus Frameworks.
Separating these two concepts is literally the bedrock of a safe deployment pipeline. Think of it this way. We have our integration strategy. This is your blueprint. It defines your intent. What signals are we exchanging? What exactly are we monitoring? What are the strict thresholds that trigger an action? On the flip side, the deployment framework is the engine on the factory floor. This is all about execution. How do we actually run the release? What automation scripts are firing off? Who acts when a threshold is breached? So the strategy is the contract, and the framework is the heavy machinery executing that contract.
And how do they communicate? Through a gate. A gate is an active control condition. To stick with our factory analogy, it's a literal toll booth on your deployment highway. The framework absolutely must stop at this toll booth and query the strategy. It demands a clear, mathematical pass or fail signal before it lets a deployment advance to the next stage. This right here, this is the magic moment where passive observability transforms into an active control plane.
Moving right along to Section 2, the 5 integration steps.
Let's step onto the factory floor for a second. This assembly line sequence builds a completely traceable provenance for every single deployment decision you make. Step 1, identify your release stages, things like staging, canary, or production. Step 2, enumerate your safety and performance KPIs for each stage and figure out who owns them. Step 3, decide your gate logic. Is it a rolling 5-minute window, a strict 1% variance? Step 4, implement the automated checks, making absolutely sure they are deterministic. And Step 5, close the feedback loop with post-release analysis. Basically, if an automated rollback happens, you should be able to trace it back through this exact 5-step process to see the precise metric and threshold that triggered it. What's genuinely interesting about this is how cleanly every stage gets assigned specific metrics and mechanical owners. For example, in staging, we really only care about synthetic test pass rates, and the gate owner is just the CI system. Easy enough. But when we move to Canary, the KPIs shift to transaction latency and error rates, and the gate owner becomes our platform automation. Finally, in production, we're looking at SLA KPIs and error budgets, which are owned by the on-call rotation. It completely removes all that stressful ambiguity about who or what is making the decision at every single phase of the rollout.
Okay, Section 3, Coding a Gate Check.
To make these checks deterministic, we need a crystal clear contract. What you're seeing is a beautifully simple, explicit TypeScript gate config interface. Notice how it defines the metric, the baseline, the tolerance percentage, and the sampling window. By writing this out as a small JSON or code artifact, we can actually version control our deployment gates right alongside our deployment scripts. This is a game changer because it means your gate decisions aren't just vague ideas floating in some forgotten document, they are fully auditable, testable code.
When we build a function to execute this config, we want a few key things to happen in sequence. First, we isolate the query metric API adapter so it fetches the state completely independently. Then, our framework executes some deterministic check gate math. It looks at the baseline, compares it to the live observation, calculates the delta, and returns a very clear, unambiguous pass or fail diagnostic payload. Depending on that Boolean result, the framework will either push the release forward, trigger an automated rollback, or halt everything and point a highly caffeinated team to a manual runbook. No human guessing involved in the moment of panic.
Now check out this tiny detail. 1e minus 9, 1 times 10 to the negative 9th. When you're writing the math to calculate percentage changes against the baseline, you absolutely got to add a tiny math guard like this to the denominator. Why? Because otherwise, a baseline of exactly 0 would trigger a division by 0 error. And just like that, your beautifully automated state-of-the-art Web3 factory grinds to a screeching, unceremonious halt. Engineering really is all about the little details, isn't it?
Which brings us to Section 4, the feedback loop.
This is exactly how a system becomes self-upgrading. Every time you release, you generate a post-release record. Did the canary pass? Did it roll back? You take that data, you review any manual overrides that were required, and you use that real-world evidence to adjust your thresholds. Maybe your gate was way too sensitive and threw a false positive, so you loosen the tolerance slightly, and then you automate the next pass. Recording deployment outcomes over time turns tacit, intuitive developer knowledge into measurable, hard-coded policy. It's brilliant.
And honestly, this concept of a self-upgrading feedback loop isn't just for software pipelines. It's about continuous improvement in everything we do. Just like automated pipelines thrive on tweaking and upgrading based on new data, developers thrive on continuous learning. It's exactly why so many of you leverage the courses and the whole learning ecosystem at Forge College. You're continually evaluating your skills, adjusting your baselines, and upgrading your knowledge to stay ahead in the Web3 space. It's the exact same logic.
And finally, our conclusion and next steps.
Let's wrap up our schematic review. If you take only one single thing away from this explainer, let it be this. Monitoring is no longer passive observability, it is an active control plane. By turning your metrics into framework-enforced gates, you completely take the anxiety out of releasing software. It makes Solana deployments, which, as we know, demand incredibly high speed and high reliability, vastly safer and entirely predictable. You are no longer crossing your fingers and hoping the system works. You are actively enforcing that it does.
In our next lesson, in the deployment module, we're taking these blueprints into the real world with aligning tasks and monitoring for deployment. We are going to map specific operational runbooks right into the gates we just designed. But before you go, I want you to ask yourself this before your very next deployment. Are you just watching your code ship, or are you actually controlling it? To dive deeper into this subject, explore more Web3 resources, and keep building out your own mental frameworks, be sure to visit forge.college. Thanks so much for hanging out with me today, and I'll see you on the factory floor.